So in this video, we'll be continuing with quadratic factorising with a focus on the difference of two squares, also known as dots. Now, when factorising an expression, it is important to see and check if you are working out the difference between two squared terms. And if this is the case, then there is a much easier way of factorising it. So if you have x squared minus y squared, then we can factorise this as x plus y multiplied by x minus y. Now before we actually move on to this, what we need to do is make sure that you can recognize what a squared term actually looks like. Now, in some cases, you may just recognize it as squared numbers, but sometimes you can have squared expressions as well, and they might not be explicit as by having a power of 2. So let's just quickly have a look at square rooting each of the following 18 terms. So here, the square root of 16 is just going to be 4. Square root of 49 is 7. Square root of 25 is 5. Square root of 121 is 11. Square root of 196 is 14. And the square root of 81 is 9. So then moving on to, let's say, more algebraic terms, then if we wanted to square root x squared, all you've got to do is ask yourself is, what do I need to square to get x squared? And that's going to be x. What do I need to square to get y squared? Well, that's going to be y. What do I need to square to get h squared? Well, that will be h. Now here we've got x to the power of 4. So here, what I need to do is square x. So here, x squared times x squared gives me a power of 4. Now, when dealing with powers, it must be an even power in order for it to be square rooted. So for example, if I had, let's say, h cubed, I can't square root that because the power is odd. So then continuing with this, I've got r to the power of 8. Well, then that will just be r to the 4. So all I need to do is just simply divide the power by 2. So that becomes 1 divided by 2 becomes 1 again there, and again 4 divided by 2 is 2, 8 divided by 2 is 4. Now when we move on to fractions, so in order for fractions to be square rooted, both numerator and denominator must be square numbers. So if the numerator and denominator contain numbers that aren't square numbers, then you won't be able to square root it as quickly. So here I've got the square root of 1 is 1 and the square root of 4 is 2. So therefore we've got a half. Now if I just quickly get rid of all of that, and so here I've got the square root of 4, which is 2, square root of 9, which is 3. Now here I can actually join terms together. Now if I deal with these separately, I've got the square root of 16 is 4, and the square root of t squared is going to be t. So here the square root of 25 is 5, and the square root of x squared is x. Here the square root of x squared is x, the square root of y squared is y. So here the answer is just going to be xy. And here the square root of 16 is 4, square root of t squared is t. Then here I've got the square root of 16, which is 4, square root of 25, which is 5, and the square root of x squared is x. And there I've square rooted all of these terms. Now what is important is that you're able to spot when something can be square rooted nicely. So you can square root it if it's a square number, you can square root a variable if the power is an even number, and you can square root fractions as long as both the numerator and the denominator are square numbers. So now let's have a look at factorising. So for this, what we need to do is basically, if you are working out the difference between two square numbers, and this is where we abbreviate it as dots, so the difference of two squares, then what we can do is we can write it like so. So here we're going to end up with two brackets, So what goes in the first term in each of the brackets is the square root of the first term. So here I've got x squared, so x squared square rooted is x. Then I've got the square root of 16, which is 4, so 4 goes in each bracket. And then one's a plus, one's a minus, and it doesn't matter which one's plus, which one's minus, as long as one of them, you've got one of each. So moving on to question 2. So again, I'm going to set up my two brackets. I've got the square root of p first, p squared, so I say. So here I'm just going to have p. And then I've got to do square root of 25, which is 5. And then one is a plus, one is a minus, and there is my final answer. So looking at this one here, I've got the square root of 81, which is a 9. So 9 goes first. And you need to make sure that the order is in the same order as what you've got in the question, or the expression I should say. And here the square root of x squared is x. One's a plus, one's a minus. Looking at question 4. So again here, the square root of 4 is 2. And the square root of x squared is x. So I've got 2x in both those two expressions. And then the square root of 49 is 7. And again, one's a plus, one's a minus. Then again, the next one, I've got the square root of x to the power 4, so that's just x squared, because I can divide the power by 2. And the square root of 144 is 12. And again, one is a plus, one is a minus. Now, as I said, it might seem quite straightforward enough, but you're going to need to be able to spot this. So again, you've got to make sure that both terms are square values, and also that you're always taking away. It's never going to be a plus, it's never going to be a divide, it's never going to be multiplying, it's always taking away, hence the name difference of two squares. So moving on to question 6. So here I've got square root of t squared, which is t, and the square root of a half, well, square root of 1 is 1, square root of 4 is 2. And again, one's a plus, one's a minus. Moving on to the next one. So this one's a little bit more complicated because I've got two squares in each term. So the square of x squared is x. The square root of y squared is y. And then the square root of 196 is 14. And square root of t squared is t. And again, one is a plus, one is a minus. Job done. So the next one I'm going to end up with 10y minus 6 and 10y plus 6. And you can see there that I've flipped my minus and my pluses, but again, they're exactly the same. Now this one's a little bit tricky because 2 is not a square number, 32 is not a square number, but I do have an even power. Now for this, what I need to do is think, well, okay, I can't use difference of 2 squares straight away, but one thing that these two things have got in common is they're multiples of 2. So let's take a 2 out. So here I've got 2y to the power of 6 minus 16. Now you can see that although I didn't have a dots to start off with, I now have a dots in the bracket. So what this then becomes is 2, and I'm going to have y cubed minus 4 and y cubed plus 4. And there is my final answer. So again, initially it didn't look like a dots question, but by using my knowledge of factorising, you can see that slowly I then discovered that it actually was. And then finally, just get the yellow back up. So here I've got square root of 25 over 49 is going to be 5 over 7. Square root of d to the power of 10 is d to the power of 5. And the square root of 36 is 6. So again, I'm just going to copy the bracket, minus 6, and there is my final answer. Now, another way that a question like this could pop up is a question that looks like this. Now, obviously, you could try and work this out manually. What I mean by that is working out what 101 squared is, then working out what 99 squared is, and then taking away the two answers. But what you need to do is recognize that this is also a dots question because I'm taking away two square values. So what this then becomes, well, the square root of 101 squared is 101. And the square root of 99 squared is 99. So now one's a plus, one's a minus. So now if I actually work this out, well, the value of this bracket is 101 plus 99, which is 200. And the value of 101 take away 99 is going to be 2, and these two things are multiplying. So the actual answer to this is going to be 400. So always look out for questions that may look like something really, really complicated, but all you need to do is just simply treat it like a dots question, and you might find it a much easier way of actually working out than rather than doing any of this. Now, another question where dots can sometimes come up in a non-familiar way is when we move on to simplifying algebraic fractions. Now, for this, what we're going to do is I'm just going to put all of these in brackets to start off with. So looking at question 1, which I'm just going to label this as number 1. Now, there's not much I could do with the denominator, but I do notice, or I should notice, that the numerator is a dot. So it's a difference of 2 squares. So with number 1, I'm going to write x squared minus 9 is also equal to x minus 3, x plus 3. And that is all over x minus 3. Now, one thing I notice here is I've got x minus 3 on both the top and the bottom, so they can actually cancel out. So all I'm left with is x plus 3, and there is my final answer. Now, if I was to include brackets, that's absolutely fine, but again, it's not essential. So moving on to question 2, which I will now label. So again here, it's not obvious that this is a dot. Well, then it isn't a dot because this is not a square. Even though it's got x squared, the 2 isn't a square number, and nor is 98. And likewise, 3x squared isn't a square, even though x squared is, and nor is 21. So let's go on to factorize this in a normal way. So the thing that the two terms on the numerator have got in common is that they are both even, and so they've got a factor of 2. So if I take 2 out, then what I've got is I've got x squared minus, and it's going to be 49, over, now what's common about 3x squared and 21 is 3. So I take that out, so I've got x minus 7. Now, one thing that I should be able to note is that here I've now got a difference of 2 squares. So here what I can do is I can write that as 2. I've got x, and I've got 49, which is 7. One's a plus, one is a minus, and that is all over 3x to the minus 7. Now again, what you should notice, I've got x minus 7 both on the top and the bottom, so I can cancel that out. So this then simplifies to give me a final answer of 2x plus 7 in brackets all over 3, and there's my final answer. Now, one thing you might also want to check is, can you simplify the 2 and the 3? No, you can't, so that there would stay as my final answer. Now, we'll include a practice worksheet along with their answers in the description below for you to practice everything you've learned in this video.